This is Sravanthi, working as Assistant Professor, Department of Chemistry in Institute of Aeronautical Engineering. Today we are going to discuss about mechanism of addition polymerization and condensation polymerization. First, what is the meaning of polymerization? So, polymerization is a process through which a large number of monomer molecules react together to form a polymer. So that means polymerization means low molecular weight compound converted into high molecular weight compound. This process is called polymerization, or monomer converted into polymer is called polymerization. So here monomer is a single, mono means single, mer means unit, single unit. So it is a low molecular weight compound. When this monomer undergoes polymerization, then it forms polymer. Poly means many, mer means parts. So number of parts or number of monomeric units repeated to give polymer. So this process is called polymerization. So polymerization is a process through which a large number of monomers molecules react together to form a polymer. So polymer is a substance that is made up of very large molecules that are in return made up of many repeating units, such are called monomer. So in this polymer, so many monomeric units, repeated units that such are called monomers. So these monomers repeated several times and form polymer. So this process is called polymerization. So monomer converted into polymer, this process is called polymerization. So polymerization is a process through which these monomers come together to form the macromolecules. So polymerization is a process through which these monomers come together to form the macromolecules. That means large molecules, repeated units, repeated monomers combined to give polymer. So to form macromolecules, the bigger, larger molecules that constitute polymer. For example, here I given styrene. So styrene is a monomer where it is undergoes polymerization. So the styrene monomeric unit is repeated several times. So then it forms polystyrene. So polystyrene is the polymer. So here styrene monomer where it is undergoes polymerization. So this styrene monomer, it is having low molecular weight. So the styrene, it is a monomer, it is having low molecular weight. That because it is a single unit. When it is undergoes polymerization, it forms repeated chain. That means it forms macromolecule. So then it forms polymer. So usually compared to monomer, it is having repeated monomeric units. So it is a high molecular weight compound. It is a high molecular weight polymer. So this process is called polymerization. So low molecular weight compound converted into high molecular weight compound. This process is called polymerization. Or rather than this monomer convert into polymer. This process is called polymerization. So now let's discuss mechanism of polymerization. So polymerization, generally each and every polymers or polymerization process consists of 3 steps. Polymerization, it consists of 3 steps which include initiation, propagation and termination. So polymerization process, it consists of 3 steps: initiation, propagation and termination. So initiation means initiator starts the reaction, and propagation means to continue the reaction. Termination, end of the reaction. So in this polymerization technique, it's involved total 3 steps: initiation, propagation and termination. So based on synthesis of polymers, so polymers have been classified into 2 types. So based on synthesis of polymers, so these polymers have been classified into 2 types: addition polymerization and condensation polymerization. Addition polymerization and condensation polymerization. See this image here, initiation. So in this process, initiator starts the reaction. This is a step 1. And here this is a propagation. That means to continue the reaction. Here this third one is termination. So end of the reaction. So each and every polymerization, It consists of total 3 steps: initiation, propagation, termination. So in this, based on this synthesis, this polymerization is classified into 2 types: addition polymerization and condensation polymerization. So what is addition polymerization? Generally, these polymers, in this type of polymerization, only addition of monomers without eliminating any byproduct. So this process is called addition polymerization. Addition of monomers without eliminating any byproduct. So this process is called addition polymerization. Best example is polyethane, Teflon, polyvinyl chloride, polystyrene. So this is the best example of addition polymerization. So in this addition polymerization to take place, the monomer must be unsaturated. In this addition polymerization, so the monomers must be unsaturated. Unsaturated means it's containing compulsory double bond or triple bond compounds like alkenes or alkynes. Only those monomers, that means unsaturated compounds, only undergoes this type of addition polymerization. Only those monomers which are having double bond or triple bond, only those monomers undergoes addition polymerization. So here taking the example of polyethylene. So it is formed by addition polymerization. Here ethylene, this is the ethylene monomer. So here N means number of ethylene monomers undergoes this addition polymerization. So in this case, ethylene monomer repeated several times. That means it forms polyethylene. This is the polyethylene. So it is a polymer. It is formed by addition polymerization. It is formed by addition polymerization. So in this process, there is no, without eliminating any byproduct, only addition of monomers. So without eliminating any byproduct. So this process is called addition polymerization. So it involves totally 3 steps. In this addition polymerization, it involves 3 steps: initiation, propagation and termination. So just now we discussed already, what is the meaning of initiation? Initiator starts the reaction. It starts the reaction is called initiation. Propagation, to continue the reaction. To continue the reaction, then gives living polymer, a large molecule, large polymer formed in this. And chain termination, that means end of the reaction. To stop the reaction, it becomes dead polymer. So total 3 steps involved in this addition polymerization. So in this addition polymerization can take place via 3 different types of polymerization or 3 different types of mechanisms. So here cationic polymerization or cationic mechanism, anionic polymerization and free radical polymerization. So this addition polymerization, it's involved total 3 steps: initiation, propagation, termination. And this addition polymerization classified into 3 types. This mechanism is classified into 3 types. What is that? Cationic polymerization, anionic polymerization and free radical polymerization or free radical mechanism. So first we'll discuss cationic polymerization or cationic mechanism. So in this case, if in case for example, initiator, here for example, initiator, here it is undergoes homolytic cleavage. Homolytic cleavage in the presence of heat or light. So in this it gives free radical, initiator, free radical. So in this case, this initiator starts the reaction in free radical mechanism. If in case this initiator undergoes heterolytic cleavage, this initiator undergoes heterolytic cleavage. So in this case, it gives cations or anions. So what is the meaning in this cationic mechanism or cationic addition polymerization? If initiator undergoes addition polymerization, so that means here cationic mechanism, if initiator undergoes heterolytic cleavage, heterolytic cleavage. So in this case, it gives cations or anions in the presence of heat and light. So here in this mechanism, the reaction is initiated by an electrophile. initiation step, it is initiated by an electrophile. Electrophile means electron deficient. Generally, these molecules are having positive charge. These molecules are having positive charge. So, resulting the formation of carbocation. Here, in this cationic polymerization or cationic mechanism, the reaction is initiated by an electrophile. Electrophile means electron deficient. That means generally these molecules are having positive charge. So this electrophile is initiated in this initiation step. And the resulting is formation of carbocation. Resulting is formation of carbocation as intermediate. Carbocation is formed as intermediate in this cationic polymerization. And next, this known as, this mechanism is called as cationic polymerization. So the reaction can be terminated by nucleophile. The end of the reaction or terminated by nucleophile. Nucleophile means electron-rich species. Electron-rich species. Generally, these molecules are having negative charge. These molecules are having negative charge. So we can summarize that in this reaction, initiator is the electrophile and intermediate is the resulting product is carbocation. Carbocation and terminator is nucleophile. It is also called as inhibitor. Here terminator is the nucleophile. So in this cationic mechanism, initiator is the electrophile, intermediate is the carbocation and terminator is the nucleophile. So already we discussed just now in each and every mechanism. It's involved total 3 steps: initiation, propagation and termination. So in this initiation step, initiator in this cationic polymerization, generally initiator will undergoes heterolytic cleavage in the presence of heat and lead, then gives cations. So here initiator is the electrophile which are having cation, positive charge. So here, for example, this is the electrophile where it is reacts with in this initiator step. This electrophile is acts as an initiator. It initiates this reaction, initiation step, where it is interacts with ethylene monomer. Ethylene monomer. Generally, it is addition polymerization. So compulsory in this monomers containing unsaturated compound. That means double bonds or triple bonds. Monomer containing double bond or triple bond. Generally, unsaturated compounds only undergoes addition polymerization. So in this monomer, it containing double bond. So ethylene monomer, it is initiated by electrophile. Here H plus we are taking electrophile. Then it gives carbocation. It gives carbocation. So this is the carbocation formed in this initiation step. So in this step 1, initiator to start the reaction. In this propagation means to continue the reaction. Finally, it gives living polymer. So in this step, this carbocation monomer interacts with. So in this carbocation monomer interacts with fresh monomer. So that means number of repeated ethylene monomers. So generally it gives living polymer. Here intermediate is the carbocation. So in this initiation step, initiator is the electrophile. It is initiated. So in this ethylene monomer, for example, we are taking this ethylene monomer initiated by electrophile. Then it forms carbocation. It is an intermediate. So next propagation step, in this case, to continue the reaction. So in this case, carbocation ethylene monomer or carbocation monomer reacts with fresh ethylene monomers or fresh monomers. Repeated several times this process. It is a continuous reaction. Finally, it gives living polymer. Living carbocation polymer is formed in this propagation step. So it is a continuation reaction. And next, termination. So termination means to end up the reaction, to stop the reaction. So in this case, terminator is the nucleophile. Generally, it is having negative charge. So this living polymer or living carbocation reacts with nucleophile. Then it gives dead polymer finally. So that means it becomes dead polymer. That means it stops the reaction, end of the reaction. So this is the cationic polymerization or cationic mechanism. And second type of mechanism is anionic mechanism. So in this mechanism, the reaction is initiated by nucleophile. But in cationic mechanism, this reaction is initiated by electrophile. But in this anionic mechanism, this reaction is initiated by nucleophile. Generally, nucleophiles are having negative charge, electron-rich species. So here, the reaction is initiated by nucleophile, resulting in the formation of carbene ion. But in cationic polymerization, it forms carbonium carbocation. Here, carbene ion as an intermediate. Carbene ion is the intermediate. So this is known as anionic mechanism. This reaction is called as anionic mechanism. In this anionic addition polymerization or anionic mechanism, initiator is the nucleophile and intermediate is the carbene ion. Intermediate is the carbene ion. So the reaction can be terminated by electrophile. It is completely reversed to the cationic polymerization. In this anionic polymerization, initiator is the nucleophile and intermediate is the carbene ion and terminator is the electrophile. Terminator is the electrophile. So we can summarize that in this reaction, initiator is the nucleophile, intermediate is the carbene ion and inhibitor, that means terminator, is the electrophile. So what are the steps involved in this? So just now discussed already, each and every mechanism it involves initiation, propagation and termination. So initiation step, generally initiator when undergoes heterolytic cleavage in the presence of heat and light, then gives cations and anions. Already we discussed just now. So here we are taking monomer. Generally this monomer containing double bond or triple bond, that means unsaturated compounds only undergoes this type of addition polymerization. So for example, here we are taking ethylene monomer. Where it is interacts with here or this monomer initiated because it is the initiation step. So this reaction is initiated by nucleophile. This reaction is initiated by nucleophile that is having negative charge. So the resulting is it forms carbene ion. Carbene ion. It is having negative charge. Carbene is having negative charge. So carbene ion formed in this initiation step. Next step to propagation. So propagation means to continue the reaction. Already we know that. So here this carbene ion monomer reacts with number of fresh monomer, ethylene monomers. Then in this case it forms living carbene ion monomer or living carbene ion polymer. Living carbene ion polymer is formed. Next is termination. Third step is to stop the reaction. So the living carbene ion polymer reacts with, that means ends, terminates by using this here electrophile. Electrophile. Then it gives dead polymer. So what is the meaning? To stop the reaction. So in this anionic polymerization, initiator is the nucleophile, intermediate is the carbene ion and the terminator or inhibitor is the electrophile. So third type of mechanism in this addition polymerization is free radical mechanism. So just now we discussed already initiator, if in case undergoes which type of cleavage? Homolytic cleavage in the presence of heat and light. Initiator undergoes homolytic cleavage in the presence of heat and light. Then in this case it gives free radicals. Initiator, free radicals. So in this mechanism the reaction is initiated by the free radical and result in the formation of living polymer also free radical, and here intermediate is free radical. That's why this mechanism is known as free radical mechanism. So the reaction can be terminated by and free radical. So we can summarize that in this reaction, initiator is a free radical Intermediate is a free radical and terminator also free radical. So what is the initiation step? So here, these free radicals, generally the initiator undergoes homolytic cleavage. In this case only it gives free radicals. So this free radical initiator initiates the reaction. So here in this chain initiation step, so here these free radicals reacts with pi electrons. These free radicals reacts with pi electrons of the monomers to produce monomer free radical. To produce monomer free radical, so which propagates the polymerization reaction. So see here, this is the monomer. So already we know that in addition polymerization, the monomers composite containing double bond or triple bond. That means only unsaturated compounds undergoes this type of polymerization. That means addition polymerization. So in this case, monomer is the ethylene monomer when it is reacts with and initiated by free radical. So free radical generally produced when initiator is undergoes homolytic cleavage in the presence of heat and light, then gives initiator free radical. So that free radical initiator initiates this ethylene monomer. For example, in this free radical addition polymerization initiation step. So in this case, it forms free radical intermediate. That means it forms free radical intermediate is formed. This is a step 1 in this free radical addition polymerization or free radical chain mechanism. Next, propagation. So propagation means to continue the reaction. So in this step, the radical site at the first monomer unit, the radical site of the at the first monomer unit attacks the double bond of fresh monomer. So here free radical monomer, the radical site of the monomer attacks with the fresh monomers, number of repeated monomers, fresh monomers. Then in this case, double bond fresh monomer molecule which again attacks on the double bond of another monomer to form another new free radical. And so on. And to repeat this process, propagation is continuous in reaction. So this radical monomer attacks or reacts with the number of fresh monomers. So in this case, it is a continuation reaction. It is repeated several times. Then it gives a radical living polymer. New free radical living polymer is formed. So finally it gives, that is the meaning, large free radical. That means living polymer is formed in this propagation step. So here, radical monomer attacks with or reacts with number of fresh monomeric units, fresh ethylene monomeric units. Then finally it gives large free radical polymer. That means living polymer is formed in this propagation process. And final one is termination. So termination means to stop the reaction or end of the reaction. So in this case, then this termination is the final step of the polymerization process. That means it stops the reaction. So it involves deactivation of the growing polymer chains. Deactivation of growing polymer chains. And that means stop the reaction by removing the free radicals. So yes, to stop the chain growth of the polymer chain carried out by two ways. To stop the reaction by two different ways. One is coupling, another one is disproportion of hydrogen. Here clearly says that termination to stop the reaction or end of the reaction. So here to stop the reaction by two different ways in this free radical addition polymerization mechanism. So what is that ways? Coupling and disproportion. Coupling and disproportions. So here termination by coupling. So in this coupling, the two free radical sites. In this coupling, two free radical sites of the polymeric chain join together and producing dead polymer. Here see propagation step, it's formed radical. That means free radical living polymer. It is also a radical site of living polymer. Free radical site of living polymer. So it coupling two free radical sites of the polymeric chain joined together to produce dead polymer. That means stop the reaction. Here two free radicals, these are combined and coupled. Then it forms a bond. That means it is a dead polymer. This is a termination by coupling in this free radical addition polymerization reactions or addition polymerization. And second type is to stop the reaction by disproportions. Determination of reaction by disproportions. Here in this case, hydrogen atom. In this case, hydrogen atom from one growing chain is transferred to the other growing chain. Transferring of hydrogen from one growing chain to another growing chain. In this way, hydrogen displacement to stop the reaction. So this is called termination by disproportions. So the chain which donated hydrogen gets stabilized by the formation of double bond. Here, stops the reaction by formation of double bond. For example, here, see this two free radical sites. Here, these two are the free radical sites of the living polymers. These two living polymers undergoes polymerization, that means termination. So here, this free radical here and this hydrogen moves to here. Disproportion of hydrogen from one polymer to another polymer. So here, one hydrogen moved to this living polymer to another living polymer. So in this case, it forms double bond. It forms double bond. So here the chain which donated hydrogen, here this chain donates the hydrogen. So in this case, it gets stabilized. It forms stable polymer. It gets stabilized by the formation of double bond. By the formation of double bond. And remaining one, which one is attracts the hydrogen or hydrogen adding polymer, it becomes dead polymer. So in this way, in this free radical mechanism, to stop the termination reaction or to stop the reaction by two different ways. One is coupling and the one is disproportion. So second type of polymerization is condensation polymerization. Condensation polymerization. So in this case, condensation polymerization means generally it is formed by the two different functional group of monomers. These are formed by the two different functional group of monomers and eliminating byproducts. So this type of polymerization is called condensation polymerization. Best example is nylon 6,6. Nylon 6,6. So how can you prepare nylon 6,6? Hexamethylene diamine and adipic acid. Then gives nylon 6,6. Then gives nylon 6,6 and water molecule is the eliminated byproduct. So what is the mechanism involved in this preparation of nylon 6,6 condensation polymerization? For example, here see in this hexamethylene diamine. Here function group is amine and here adipic acid, its function group is diacid. Both are undergoes condensation polymerization. Then it forms polyamide. Then it forms polyamide functional group. Polyamide function group is formed. So this is the mechanism involved in this nylon 6,6 condensation polymerization. So it is formed by the hexamethylene diamine and adipic acid. In hexamethylene diamine, it involves diamine functional group. And here diacid, adipic acid. These two are undergoes condensation polymerization. In this case, it forms polyamide and byproduct is water molecule. Byproduct is water molecule. One more example is terline. So terline is the best example of condensation polymerization. It is prepared by the terephthalic acid and ethylene glycol. Ethylene glycol and terephthalic acid undergoes condensation polymerization, then form terline. It is also called as dacron or polyester. And byproduct is water molecule. Byproduct is water molecule. Here, function group is diacid. What is the function group involved in this terephthalic acid? diacid. And here diol, 2-hydroxy functional group, diol. So in this sterline, terephthalic acid diacid functional group and ethylene glycol diol functional group. So these two are undergoes condensation polymerization. In this case, it form ester link. It form ester link. And elimination of byproduct is water molecule. So this is the mechanism of terline in this condensation polymerization. So what are the difference between addition and condensation polymerization? So already we know that addition polymerization is also called as chain growth polymerization. But in condensation polymerization it is also called as step growth polymerization. Because in this addition polymerization, chain growth means only addition without eliminating any byproduct. That's why this polymerization is called addition polymerization. But in condensation polymerization, it is formed by the functional group of monomers and eliminating byproducts stepwise manner. So that's why it is called step growth polymerization. So here it takes place only in monomers containing multiple bonds. That means unsaturated compound, the monomer containing double bond or triple bond. Only those monomers undergoes this type of addition polymerization. But here it takes place monomers containing functional group. Functional group of the monomers only undergoes condensation polymerization. And here the concentration of monomers decreases steadily throughout the reaction. But here the concentration of monomers disappears early in the reaction. Here elimination of simple molecules does not take place. That means without eliminating any byproduct, simple molecules without eliminating in this addition polymerization. But in this elimination of simple molecules like water, ammonia, HCl, etc. they are essential. Only simple molecules and byproducts are eliminated in this condensation polymerization. And here high molecular weight polymers is formed because it is a chain growth polymerization, only adding without eliminating any byproduct. So obviously molecular weight also of this polymer is very high. But here the molecular weight of the polymer rises steadily throughout the reaction. Changes throughout the reaction. The best example of addition polymerization is polyethylene, polystyrene, propylene, polyvinyl chloride, etc. But in this condensation polymerization, examples is terline, nylon 6, nylon 6,6, etc. So today's session will learn about what is the mechanism of addition polymerization and condensation polymerization. What are the steps involved in this? Generally, in each polymerization, it involves initiation, propagation, termination. These three steps involved in this addition polymerization. And again, this addition polymerization classified into two types: cationic polymerization, anionic polymerization, and free radical polymerization. So what are the steps involved in these three types of polymerization? Initiation, propagation, termination. So what is the meaning? Initiation, to start the reaction. Propagation, to continue the reaction. Termination, to end up the reaction. That means stops the reaction. So these three steps involved in this, all these three types of mechanisms of addition polymerization already we discussed just now. And also we discussed about condensation polymerization and nylon 6,6 preparation and what are the bonds formed in this terline. Also we discussed just now. And what are the differences between addition polymerization and condensation polymerization we learned in this session. I hope understood all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.